I'm covering 2-3 today, which is graphing linear functions, and we are going to determine whether a function is linear or not, and then we're going to graph a linear function given 2 points, a table, an equation, or a point and a slope. So functions with a constant rate of change are called linear functions, and we've learned to write linear functions well in a couple forms. The most common is f of x equals mx plus b, where x is our independent variable, m and b are constants, m is our slope, and b is our y-intercept. So the graph of a linear function is a straight line, hence the word linear, made of all points that satisfy the equation y equals f of x. So the equation is just would give us a set of points. If we graphed every single point for each x value, it would form a straight line. So the graph is just a picture of what the values values from the equation look like. The constant rate of change for linear function is called its slope, and we know it's the ratio of, we used to call this f of x, of y, but now we call it f of x. So the change in f of x over the change in y, which also we know is rise or run. This is our vertical change. The rise is our vertical change, and the run is our horizontal change. So determine whether the data set could represent a linear function. So remember, if it's linear, we have a constant rate of change. That means that our change in f of x or y has to be constant, and our change in x has to be constant. So let's look. Here's our table. Here's our x values. Here's our f of x. If we look at what happened between these two values, we added 2. What happened between these two values? We added 2. Again, we added 2. So we have a constant change in x. What about our f of x or y? Well, as it says here, from 2 to 1 we subtracted 1. From 1 to 0 we subtracted 1. From 0 to negative 1 we subtracted 1. So since both our change in x and our change in f of x are constant, we can say that this is linear, and in fact we found what our slope is. So the rate of change is a negative 1 over 2, or negative 1/2. Next example, here's our data set. So we added 1, we added 1, we added 1. What happened here? We added 2, we added 4, we added 8. So it's a constant. There's a pattern to that, but it's not constant. The amount we're adding changes each time. So because of that, this is not a linear function. All right, so one for you to try. And I kind of gave it away there, so at least part of it. So see if you can figure out whether that is a linear function or not. All right, we're going to get into graphing now. Graph the line with a slope that passes through the point -1, -3. So how are we going to graph this? We don't have an equation, but we have enough information to graph the line. Remember, you only need 2 points to graph a line. So first thing you're going to do is plot your point, -1, -3. Remember, this is our x-coordinate, or horizontal. This is our vertical, or our y-coordinate. So -1, -3 is right here. And now we're going to use our slope to find a second point. So we have a vertical change of a +5. So we're going to go up 5 from this point. And some of the confusion I see is people want to start from the origin. Don't start from the origin. You're starting from the point that you just plotted. So we're going to go up 5, 1, 2, 3, 4, 5. And then we have a horizontal change of 2. So we're going to go right 2. 1, 2. So now we have our second point. And from there you just graph the line that connects those 2 points. So pretty simple. This is similar, but notice we have a negative slope. And I can tell you how I deal with negative slope, but you can choose to do it differently. So again, we're going to plot the point 0, 2. The line goes through that point. So 0, 2 is right here. So whenever I have a negative slope, I use that to change the direction of my vertical change. That way, for horizontal change, in my slope, I always go right. Doesn't matter whether this is positive or negative. If I have a negative slope, instead of going up on my vertical change, I'm going to go down. So I'm going to go down 3, 1, 2, 3, and then I still go right 4 because I've taken care of the negative by going down. So 1, 2, 3, 4. There's my point. Connect the line, or draw the line that connects those 2 points, and you're done. And it would be nice, since it is a line, to put arrows on each end. All right, so here's one for you to try. Slope of 4/3 that passes through the point 3, 1. All right, so let's look at intercepts. The y-intercept is the y-coordinate of a point where the line crosses the x-axis. So I think these are actually not right. Where the line crosses, I think this should be the y-axis, and this should be the x-axis. So you can see here's our y-intercept. The line is crossing the y-axis. And the other thing about the y-intercept, you know that the x-coordinate is going to be 0. Our x-intercept, I think these probably should be switched, but anyway. So here's our x-intercept, and you can see it's where it's crossing the x-axis, and our y-coordinate here is going to be 0. And that's important for the next thing we're going to be doing, is to understand y-intercept has an x-coordinate of 0, x-intercept has a y-coordinate of 0. Find the intercepts of the equation 4x minus 2y equals 16 and graph the line. So remember, the x-intercept, y is equal to 0. So how are we going to do this? We're going to set y equal to 0 and solve for x. So I substitute 0 in for y. I end up with this, divide by 4, and I see that I have an x-intercept of 4. So I can plot that point. That's my first point. It's going to be 4, 0. Now when I find my y-intercept, and remember here x is equal to 0, I substitute 0 in for x. I'm left with this. I divide by my negative 2, and I get negative 8. So that gives me a point. So I should put this here. It gives me a point. This gives me a point 0, negative 8 that I can plot, which is here. And then now I have my 2 points. I connect those points with my line, and I'm done. So if your equation for your line is not in traditional form, which is y equals mx plus b, this is a nice way to find points to graph the line. So here's one for you to try. You should make sure you know how to do it. All right. Write the function negative 4 plus y equals negative 1 in slope-intercept form, then graph the function. So once we have the equation in slope-intercept form, again, it's pretty simple to graph that function. So that's another way to graph, by just changing it into a form that we're familiar with, slope-intercept, and graphing it from there. So what do we want to do? We basically want to solve for y, or get the y all by itself. So it says solve for y first. What do I have to do? I just have to add 4x to both sides. Now I have the equation in slope-intercept form, and for some reason it's not here. So it's going to be y equals 4x minus 1. So slope-intercept form, we know that y equals mx plus b. This is our slope. This is our y-int. So here, the line has a y-intercept of negative 1. That means it has coordinates of 0, negative 1. So we plot that point. And then just like we did a couple slides before, we use our slope. If it's a whole number, then that means it's a whole number over 1. So our rise is 4, our run is just 1. So we're going to move up 4 and write 1. 1, 2, 3, 4, and then connect those points. So we have at least 3 ways of figuring out how to graph a linear function at this point. Here's another one. So first, we're going to multiply, first thing we're going to do is subtract x from both sides. That's not shown here. And that's where we get to negative x plus 6. Now to get rid of the 3/4, we multiply both sides by the reciprocal. Remember, when you do that, we're multiplying this whole expression. So that means I'm going to multiply this by 4/3 and this by 4/3. And that's going to give me a negative 4/3 x. 4/3 times 6, remember it's going to be 4/3 times 6 over 1. Multiply across your tops and bottoms. 24 over 3. 24 divided by 3 just gives us an 8. So we end up with negative 4/3 plus 8. This is our y-intercept, so it's 0, 8. Plot that point. And then we have a negative 4/3 slope. So from here, I'm going to go down 4, 2, 4, and over 3, 2, 3. And now I can draw the line connecting those points. Okay. So there's one for you to try. Write it in slope-intercept form and graph. The last thing that I want to go over are vertical and horizontal lines. They're kind of special cases. So a vertical line, it has an equation x equals a. In this case, if we assume these are 1 unit, this one's going to be, the equation for this is going to be y equals 3/2 or 1.5. Notice what it says. The slope is undefined because x2 over minus x1, since x never changes, is going to be 0. So we're going to have a fraction with 0 in the denominator, which makes it undefined. So slope is undefined for vertical lines. What about horizontal lines? Well, notice in horizontal lines, the y value stays constant. So this equation would be 1, 2, 3. So y equals 3.5 or 7/2. And in this case, our slope is 0 because x will change, but y will never change. So if I took this point and this point as my x2, x1, so I've got 3 minus 1 over 3.5 minus 3.5. That gives me a 0 over 2, which is 0. Unlike if I had this, excuse me, if I took this point and this point, I'm going to get 0, actually 3 minus 0 over 1.5 minus 1.5. That's going to be 3 over 0, which is undefined. So vertical lines undefined slope, horizontal lines have a slope of 0. Okay, that wraps up this lesson. Homework. Bring any questions to class.